Today I'm gonna talk about the derivative of composite function, the application of two chain rules. We're gonna focus on the trig function and logarithmic function. Now let's take a look at the following formulas. The first formula is a typical chain rule. The capital F can be any trig functions. So if capital F is sine, then the derivative of f is cosine. If capital F is cosine, the derivative of capital F gonna be negative sine. If capital F is tangent, then the derivative of capital F gonna be secant square. And the second formula is the derivative of composite logarithmic function. The derivative of ln fx equals 1 over fx times the derivative of fx. The third one is standard power rule. The fourth one is the constant multiple rule. And I also list the derivative for three trig functions. Now let's take a look at the first function. The first function is about sine ln 2x. Okay, so what's the derivative of this guy? We're gonna apply the chain rule. Here the capital F is sine. Okay, and what is little fx? That is ln 2x. So we write down the little fx equals ln 2x. Okay, now we're gonna apply this formula. Derivative of capital F, derivative of sine gonna be cosine. Cosine fx is ln 2x times derivative of little fx. Here is ln 2x. So it's ln 2x prime. Okay. Now, how to do the derivative of this guy? We're gonna apply the second formula. For the second formula, we need to figure out the fx. So we can tell the fx is 2x. So fx equals 2x. Now we can apply the formula 2 for this derivative. We have cosine ln 2x times 1 over fx, gonna be 1 over 2x times the derivative of fx. And we know for the derivative of 2x, that is constant multiple rule, right? We can pull this 2 out of the derivative. So we have 2 times x prime, and the x prime is 1. Okay, now we can simplify it. Cosine ln 2x 1 over 2x times 2 times 1 is 2, and we also can cancel out these 2, and we have cosine ln 2x over x. Now let's take a look at the second example. For the second example, we have the function cosine ln 3x squared plus 2x squared. We can apply the first formula, chain rule. What is capital F? Capital F is cosine. And what is little fx? That is here. So little fx equals ln 3x squared plus 2x squared. and then we can apply this formula. The derivative of capital F, the derivative of cosine, gonna be a negative sine, okay, times fx. So it should be fx should be ln 3x squared plus 2x squared times the derivative of little fx. So we have ln 3x squared plus 2x squared, and for the derivative of these two functions, derivative of the sum of these two functions can be the derivative of the each function. Okay, so we have sine 3 ln 3x squared plus 2x squared times the ln 3x squared prime plus 2x squared prime. Okay, and let's take a look the second term. The derivative of 2x squared, we can apply the constant multiple rule. It should be a 2 times x squared prime. And now let's take a look the first function, ln 3x squared prime. So how to do the derivative of this guy? We're gonna apply the second formula. For the second formula, we need to figure out the little fx or fx, right? Fx equals 3x squared. Okay, then we can apply the second formula. We have sine ln 3x squared plus 2x squared, and this guy gonna be a 1 over fx. So 1 over 3x squared times the derivative of fx. Okay, and plus here is 2 times 2x to the power 2 minus 1. Okay, and again for the first term here, we can apply the constant multiple rule. Okay, and this guy actually can be written as 3 times 2x to the power 2 minus 1 power rule. Okay, so we can continue to simplify it. So we have ln 3x squared plus 2x squared 1 over 3x squared times, here is 3 times 2 is 6 x plus here is 4x, and now we can cancel 1x here, cancel 1x here, and 6 divided by 3 is 2. Okay, now we can simplify it. Negative sine ln 3x squared plus 2x squared, we have 2 over x plus 4x. Okay, now let's take a look the last example. For the last example, again we can apply the chain rule. What is capital F? That is tangent. Okay, and what is little fx? That is 3 ln pi x. So we have little fx equals 3 ln pi x. Now we can apply the chain rule. The derivative of capital F, that means derivative of tangent, equals secant square. And fx, little fx is 3 ln pi x times the derivative of little fx, 3 times ln pi x. Okay, and here we can see 3 times this function. We can apply the constant multiple rule. We have 3 times ln pi x derivative. Okay, so we have secant 3 ln pi x times 3 ln pi x derivative. Okay, now we're gonna apply the second formula to solve this derivative, and we can tell what is fx. Fx is pi x. Okay, and then we can simplify it. Here the 3, we put the 3 in front of this function. 3 ln pi x times 1 over fx. Fx is pi x times the derivative of pi x. And again, we know the pi is a constant, so we can apply the constant multiple rule. We're gonna have pi times x prime. Okay, and x prime here is 1. So basically we can simplify it. 3 times secant 3 ln pi x times pi over x times pi. Okay, and the pi we can simplify it, and we're gonna get 3 secant square 3 ln pi x divided by x. That's it.